Hi, welcome to our third lesson of the Biomechanics unit. So we're going to start this lesson with a recap exam question. So if you want to stop the video and give yourself 10 minutes to complete these 3 exam questions, so 10 minutes, and then we'll go through the answers. So if you stop your video now. Okay, so the answers for the exam questions. So the first one, a sprinter generates momentum. They have a mass of 70 kilograms and they run at a velocity of 10 meters per second. So the first question is define and calculate the sprinter's momentum showing your workings. Now there are 3 marks available and you need to remember that it says define and calculate. So there's 2 parts to the question. So the first part of the question is to define momentum. Now momentum is also known as speed. So the answer to the question is the quantity of motion possessed by a moving body or the impetus gained by a moving object. That will get you 1 mark for defining momentum. Now the other 2 marks, so you get 1 mark for working out the correct calculation. So momentum or speed is also calculated by mass multiplied by velocity. So we're looking at 70 multiplied by 10. You'd get 1 mark for that. And then you get 1 mark for the correct answer, but you must have the correct units to gain that mark. So it's 700 kilograms per meter squared or kilograms per meter squared, but you've got 2 different ways of writing that, and they're both correct. Okay, so question number 2 is at what velocity must a 100 kilogram athlete run to have the same momentum as calculated above? Now for this question you need to remember our triangle. So if mass multiplied velocity are at the bottom and speed or momentum is at the top. So the calculation would be speed, because we have that, the momentum we have that, the top part of the triangle is 700. We would then divide that by mass, because we have that, the mass is 100 kilograms. So the answer would be 700 divided by 100 equals 7 meters per second, or 7 meters per second squared. And that will get you 1 mark. So the third question was describe how the force of weight acts on a sporting body. Using examples from sport, explain 3 factors affecting air resistance. So there's 2 different parts of this section. Now the first part, talking about force, about weight and the force that it acts on the body, that will get you a maximum of 2 marks. And you get 2 marks for saying it's a downward force, it acts from centre of mass, and it's due to gravity or gravitational pull. If you've said 2 out of 3 of those things, you will get the 2 marks. The second part of the question, so talking about factors that affect air resistance, so you will get you'll get 1 mark for each factor identified, as long as you've given a sporting example as well. And you can only count the first 3 that you have written down. Okay, so you will get marks for saying about frontal cross-sectional area. If you decrease that cross-sectional area, then you will decrease air resistance. And sporting examples are a sprinter tucking in their head and hands and lifting their knees high. You'll get a mark for saying about shape or streamlining. So you can talk about an aerofoil or a teardrop shape, creating airflow around the shape, decreasing the air resistance. Now the example they've given here is the shape of a discus in flight, but you can talk about a cyclist helmet, you can talk about a Formula 1 racing car as well. They are all valid examples. The next one is surface characteristics. So is it smooth, is it rough? So, and saying that a smooth surface will decrease air resistance. Give the example of lycra suits in speed skating, or cyclists shaving the hair off their legs and things to decrease that air resistance. Another one is speed velocity. So an increased speed or velocity will increase air resistance. An example is anything travelling fast. So the example here is the high speed of a sprinter will have a higher air resistance than someone walking. But any sporting examples along those lines you will get the mark for. And the final one is air density. So a decrease in air density will decrease the air resistance, because there's less air to resist, if that makes sense. So for example, drafting in cycling, what that is when a cyclist will ride very closely behind another cyclist, because there's the way the airflow moves, there's less airflow hitting that cyclist behind, and therefore they have less air resistance and can actually get a bit of speed gained. Or any object, javelin, shot put, hammer throw, anything like that, if they're being thrown at a high altitude, then they will travel further. There's less air resistance. A lot of the world records for the throwing events are set in places of high altitude. Okay, so this lesson is, we're going to go back over centre of mass, because I know you did, you looked at a video last week on centre of mass, but it's quite a tricky concept to understand, and so we're going to go back through it and have another perspective on it. So by the end of the video, hopefully you'll be able to define centre of mass. You'll be able to identify and explain factors that affect the position of the centre of mass, and then you will be able to discuss the relationship between centre of mass and stability. So centre of mass, as we know, it's an imaginary point. It is movable, and it's where the mass of an object is mainly concentrated. So you can see here, centre of mass is right in the middle of that person's body. Now, as the mass of the arms move up, so the body moves position, the centre of mass will move position as well. It will move upwards because the arms have gone upwards, so the mass is, the concentration of mass has to move upwards as well. Now, stability, how stable an object is very dependent on the centre of mass being directly above the base of support. Now, the base of support is the line where the points of contact lie on the ground, and the centre of mass has to be over that base of support. So if I go back to this image here, the centre of mass is over the base of support, it's a stable position. Now, if the base of support is smaller, it's less stable. However, the centre of mass and the line of gravity is still over the base of support, they're still going to be balanced. Whereas here, the centre of mass and the line of gravity is not over the base of support, and therefore this is an unstable position and an unbalanced position. Now, centre of mass does not always need to be inside the body, which is the tricky bit to understand. The mass of this body is still concentrated around that point, but that point is not inside the body now. Stability is dependent on 4 different things, and these things you need to consider: the position of the centre of mass, the size of the base of support, the mass of the athlete, and also where the line of gravity is. Now, a bit of a recap. So centre of mass is the point at which the body is balanced in all directions. So the mass of the body is the amount of material of which it's made. So for example, a shot put will have a much greater mass than a football, because a shot put is made of heavier material, heavy metal, and it is solid through, whereas a football is full of air, so it has a less mass. Now, the centre of mass is the point where all of its mass is concentrated. It's not fixed, so we know that when you're standing upright it's in your stomach, but if you move, then the centre of mass can often move and lie outside your body, and its location will vary depending on your body position. So there are 3 further YouTube videos. I would like you just to pause this video and watch these 3 YouTube videos. Okay, so what happens to the centre of mass when you move? So you can see here the images. You just need to be aware that when your body moves, your centre of mass will move. Okay, so you've got a person doing a squat here, the centre of mass lies outside of their body, but if that person then raised up from that squat, then the centre of mass would then lie inside their body. And here you can see same person doing lots of different body positions, and their centre of mass is in a different position for each body position. Okay, so I'd like you to have a go at answering this exam question. So for 3 marks, describe how a sports person can maintain their balance using the concept of centre of mass. I would like you to pause the video and give yourselves 2 minutes to answer this question. Okay, so answers. So describe how a sports person can maintain their balance using the concept of centre of mass. You will get a mark for saying any of these points. So you will get a mark for saying that the centre of mass continually changes as the body moves. To maintain balance, the centre of mass must be over the base of support. If the centre of mass moves out of the area of support, then balance is lost. And the larger the area of support, the easier to maintain the balance. The more points of balance, the easier to hold, and raising the body raises the centre of mass, so decreases stability. A centre of mass lower to the ground is much more stable. Okay, so looking at stability, this relates to how difficult it is to disturb a body from a balanced position. How easy is it to move that body out of that position? So line of gravity, remember, is the line that extends from the centre of mass vertically down to the ground, and it needs to be over the body of the base of support in order for it to be a stable position. Now here you can see the gymnast, he's hanging off of a high bar, it's stable, he's relatively hard to move from that position. Whereas if he was reversed, his centre of mass is actually slightly higher up because the legs have higher mass than the arms. So when he's hanging, his centre of mass is fairly low down. Whereas when he's in a handstand position, his centre of mass moves up, and therefore it makes it slightly less stable. It's an unstable position, and if he's lying flat, then it's neutral. Now, to remain balanced, centre of mass, we know it must be over the base of support. A stable body position will enable an athlete to resist motion. We look at that, and the stability of an athlete is determined by the following: the position of the athlete's centre of mass, the base of support, the line of gravity, and the mass of the athlete. Now you can see from this image here, the position of the centre of mass is not over the base of support, and therefore the athlete will topple to the right. So here are some images. So we have someone performing martial arts. You can see here that their base of support is really wide, and their line of gravity is straight directly over the middle of the base of support. This is a really stable body position. Now here we can see that their line of gravity is still over their base of support, but the base of support has reduced dramatically, and therefore this is a much more unstable body position. Again with the rugby player, so here, you know, if you're looking to tackle this rugby player, he's got a relatively small base of support, his legs are together, you know, he's not going to, you know, be able to stop anyone running through him. Whereas this person, wide base of support, much more stable body position, he's going to be more likely to be able to stop any runner. The gymnast here, you can see line of gravity, it's a small base of support, but the line of gravity is directly over the middle, and therefore she's going to be relatively stable. Whereas here, the body position has changed, the centre of mass has shifted, and the line of gravity no longer lies in the middle of the base of support. Therefore she is now unstable and likely to fall off of the beam. So, just to make you aware, base of support, it refers to the area, as we've discussed, beneath an object or a person that includes every point of contact. So this person here doing a handstand, their base of support is between those two hands there. Whereas this person here doing a headstand, the base of support is a little bit larger. And you have to include every single point of contact. So here we've got two hands and the head. And the points of contact may be made with body parts, for example the hands or the feet, but they can include things like crutches or a chair that the person's sitting in, or anything else that is supporting their weight. And the final thing we need to look at is centre of mass and the application of force. So the direction of the force being applied to the centre of mass will dictate if the motion is linear or angular. Now we looked a little bit at this in our last lesson. So linear motion is straight, angular motion is rotation. If the line of the force is through the centre of mass, the resulting motion will be linear. So it's a direct force, for example a vertical jump. However, if the line of force passes outside of the centre of mass, then the motion will be angular. For example, a somersault, and this is also how we get spin onto a tennis ball or, you know, a cricket ball when it's being bowled. And rotation, so angular motion, is called an eccentric force. What's something that is offset from the centre of mass. So here we can see linear motion, that we've got a ball here and the force is being directly applied straight through the middle of the centre of mass, and therefore the ball travels in a linear motion, a straight motion. It will just go straight up with no spin. However, with this one, you can see the centre of mass, the force is being directed off to the side, and therefore the ball will spin and it will cause angular motion. Now, if you need more spin on the ball, then the force needs to be greater and further away from the centre of mass. Okay, what I'd like you to do, this brings us to an end of the centre of mass section. I would like you to go back over the video, make notes through everything, make sure you understand it all before watching video 4, which is all about levers.